Let's briefly review how to read in data from a file using objects created from the scanner and file classes. So I have a couple of files to read. Temps.txt, data2, data2.comma, or dash comma.txt, and a few programs that can read from that. So let's start with the simplest one, which is read nums from text file. We'll open it up. We're importing scanner and file. Obviously, you can just do import java.util.star java.io.file. We have the class name, the main method, and since the main method has a situation where we're reading or creating a new file object from a file, it needs to throw an exception. This is, when we talk about exception handling, we'll understand why this is the case. This is something called a checked exception. And so we have to handle it, where the Java is forcing us to handle it somehow. What we're choosing to do with throws exception is just say, all right, you know what? I don't feel like dealing with it, so I'm just going to kick it down the road. And this throwing of the exception throws it to the console, essentially. So, but we're kicking the can down the road. Typically, we're going to want to handle it in a nicer fashion. So we open the file. This is a reference to a file in the same directory, but obviously we could do, C:\\/ blah, 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 to a specific location. In fact, I believe, if I'm not mistaken, we might be able to do something like this. Grab it from a URL. I'm not positive, but I'll tell you what. I'm going to try it. So I have my little website here in CSN Linux land is csnlinux.genesee.edu /temps.txt would be the name of the file. Why not? Let's just try it. I'm going to grab it, copy. And my little location on the web is my public HTML. I don't want to get into too much detail. Those of you who are taking my scripting class know what this is all about. Well, let's see if this works. Okay, if not, it's going to throw an exception. Compile it. It'll compile. And run it. Seems to be working really hard. So I suspect something is going wrong here. Unless I just didn't read my something. So let's just leave it as a local file for now. And I'll work out the details of URLs later. Okay, so files in Java IO reads. This is a relative path relative to where the file, where the Java file lives, and we're creating a scanner object. But instead of reading from standard in, which would be system.in, we're reading from the file object. Once you create your input, and this would be SCF. Okay, once you have your scanner objects, in this case SCF is what I called it, you can actually tell it to use a delimiter. And a delimiter is just a string that separates one element from the other. I'm choosing not to do that here. The default is any white space. We start out, I'm in the code, what I'm doing is we're setting temperature equal to 0, and we're saying, hey, while my scanner file or my scanner object has an int, a head, read it with next int, print it, and update my counter. Counter starts at 0, so every time I read something in, and then I close it out. And so, and I think I should probably have some sort of final. No, so I don't, for some reason I'm not. Let's do a system out println total temps red is going to be plus counter. Compile and run it. Okay, so I read in a bunch of temperatures. I terminated at the point where there wasn't a next int to be read. Total temps read is 15. And if we look at the image file, or sorry, the temps file, notice it has a bunch of stuff, and then I stuck in this word nothing. But let me move this up now to something that's not an int. So 64.2 is not an int, it's a double, right? So it's going to look ahead. The scanner is going to look ahead and say, hey, that's not an int, so I'm done. So we do that. We run it again. Take a look at the output. See, now it only got to the 55. It looked ahead. It said, hey, it didn't have a next int. And so my while loop terminated. All right, while it has that, we continue. As soon as it doesn't, we break out and print out the answer. All right, so that's how we read data one line at a time, or one element at a time, using the scanner class attached to a file object. And there's nothing magical about the temperatures being on the same line. As long as there's some white space, it will do just fine reading them, right? Just to verify. And see, same thing. Okay, so nothing, as long as there's white space separating the elements, we're good. The next program, this program demo is using the scanner class and the file class to read input directly from a file into a scanner, same thing. But the idea here is that data2.txt, let me bring that up. Has 3 elements per line: a string, a number, an int, and then a double. And it's important that the string doesn't have any spacing in it, because remember, white space is the delimiter by default for a scanner object. So if I were to change this to string ABC, which I can show you in a little bit, the program's not going to function as expected. But let's just say we have a formatted file, a string, an int, a double, a string, an int, a double, and so on and so forth. This is how we would read it. Again, same thing, scanner and file, set up your file object, set up your scanner object, reading from the file now. This time I call it input. While input has next. What does has next do? Has next just verifies that there's something that it can read. Okay, when we're at the end of the file, and only when we're at the end of the file, has next is false. But right now it's going to be true, and so we read in a string. Next, we'll read any tokens up to, but not including, spaces. So we'll read whatever it can consume here until it sees a space, or any white space. Then it does the same with an int and with a double. I guess we're updating, we have sum equal to 0, and we're going to add up the ints for some reason, counting the number of lines, and then printing out the data, my string, my int, my double. And of course, we could print out the sum, but just to kind of get a sense of what's going on, let's just run it. And you see it prints out the string, the number, and the double. And of course, we don't have to print it out in that order, so let's just do it backwards. So instead of 15S, let's do the 10D first, or let's even do an 8D. And then 12S or 15S, and a 9.2F, just to, to mix things around. As long as we read them in, we can print them out any way we want. Compile, oops, and run. And oh yeah, I have to pass the arguments to the printf in the correct order, so this has to be my int now, and my str. Okay, same idea. Okay, where is this going to crap out? Well, there's a lot of places where it can crap out. If the data file is inconsistent, meaning if this turns out to be a double instead of an int, we're going to crap out right there. And we'll throw an exception. And the exception was input mismatch exception. So it tried to read an int and it got a double. The other thing that could possibly happen is we run out of data before we expect to. So the way we could do that is, what if we didn't have a double there on that last line? Well, we're going to hit no such element exception, because it tried to read a double and it didn't get one. So you should probably, if you want to be careful, either we're going to wrap this in some exception handling, or we want to test has double, has int, or has next int, has next double, has next. And then in any of those situations, if it doesn't, break out of the loop and be done. Finally, you want to make sure that, as I mentioned, you can't have any spacing in here, or it's not going to know what to do. It's because it's going to read has next, is going to be Java because he sees white space, and then the next, it's expecting to have an int here, it gets a string, it'll crap out. So again, this last time, that exception is, again, no such element. I think maybe I didn't save the file. I was expecting an input mismatch. Yeah, okay. Because it wanted an int, but it actually got is fun. So what if you really do want to have spaces in your strings? I mean, most strings, sentences have spaces in them. So what if we really did want to say Java is fun? Well, we have a way to handle that. You could mess around with delimiters on, let me save that back. You could mess around with the delimiters, as I mentioned in this file. You could try to do a use delimiter, but actually that gets tricky because the way that you want to differentiate between spaces between numbers and spaces, so it gets tricky. However, in this last situation, for this data2 with comma, what I did was I comma delimited the data, and then I made sure that each record appears on a separate line. So the first line is string, and I can even put A, B, C, all separated by spaces, comma 23, comma 44, 1. New line, boom, new line. Now the new line is considered to be white space. So what we're going to do essentially is we're going to read an entire line at a time and then split it up on commas. Okay, this is a standard comma separated value file. So let's save it and take a look at the solution. Same setup, file and scanner. Okay, open up your file object, create your scanner object with the file. So now what we're going to do is temperature is equal to 0 while input has next line. As long as there's another line to be had, we're going to read in the entire next line. So we're reading that, slurping it a line at a time. Set it equal to my string, which is defined up here, and trim it. Trimming it means that we're removing the white space from the ends. Now what we're going to do is we're going to split the string using the split comma method. Strings have a split method, and what that does is it splits it up into an array of strings. So we're going to want to do let me keep that comma there. What we're going to want to do is create a string array called strarr, or whatever you want, which is going to equal my str.split, and we're going to split it on comma. Now you got to be careful because it's possible that comma delimited files might have some spacing in here. We're going to assume for the purposes of this discussion, there's no spacing between the commas and the data. All right. So this will, where am I? This will split up that line at commas into as many elements as there are. Now we do need there to be a consistent format to that record. And in this particular case, the first piece or the first element, which is element 0, is going to be a string, then it's going to be an int, then it's going to be a double. Okay, that is required, and you want to maybe check for that as well. But what we can do here is we can reuse MyStr. I mean, that's probably a bad practice, but let's do new str equals. It's just going to equal MyStr sub 0, right? This breaks up into 3 pieces or whatever. The first piece is going to be the string. The second piece, and that should be, we've got to declare that. The second piece is going to be an int. And I think I already declared it up there, so I don't have to redeclare it. Now, it would be nice just to say this. It's going to be str1, right? The first element in that freshly split string. This is going to give us a syntax error because this is a string and this is an int. So the way we can fix that is, remember the integer class. We're going to be revisiting this quite a bit in upcoming weeks. The integer class provides us with a parseInt method that will take a string and attempt to convert it to an int. Again, something is, all right, oh, I'm sorry, this should be strarr. Right? What I'll ask you to do is, I'm going to shut this down because now all you really have to do is just print out the pieces. So system out printf. And it doesn't have to be a printf. It can just be a println if you wanted to. But just for argument's sake, s. Let's do it this way. And f.2 or 0.2f. And we're going to do new string. MyInt and my dub. Just for the heck of it, let's set my dub equal to 0 up here. And what I'll ask you to do is, all you have to do is just, this should work. In fact, it'll compile now, and it will run. It's gonna split the string at the commas, create a new array every single time through. The string array is gonna equal the new values. New string is equal to str array 0. MyInt is gonna equal to the first argument or the first element in the string converted to an int. What I want you to do is just convert the second part to a double, and that's going to set it equal to my dub, and it should just print out and work. What we're going to end up having here is that last one is 0 because we haven't actually parsed it. But look, the string's converted correctly, the int's converted correctly, so you just do the doubles. All right, so that's it for today. And the reason we do the reading from the file is because your project, your next project, is going to it's going to involve reading from a file. So I'll quickly go over this. So the project is a college curriculum survey, and in a nutshell, what we're going to do is we're doing a big survey from all the students that have gone to Genesee Community College or whatever college you want. And we've classified all of our students into one of these 6 programs. 0 is fine arts, 1 is social science, 2 is humanities, 3 is math science, 4 is business, and 5 is health. For each of these students, we simply ask them to give a grade to the program. 0 is an F, 1 is a D, 2 is a C, 3 is a B, and 4 is an A. The survey.txt file, which we're going to read in, consists of data that's just pairs of numbers. What the first pair of numbers means is that the 3 on this first line corresponds to curriculum code 3. So that means this is a person from math science, and that person gave math science program a grade of 4, which is an A. The second line means fine arts student gave it a grade of D. And what we're doing is we're keeping track of all this data in a grid that looks exactly like this, a 2-dimensional array that looks exactly like this. We're just keeping track of all of that data. And so your job is write a class called curriculum that reads in this data and populates the matrix accordingly. So once the matrix is populated, it should look something like this, where each element, so let me just choose this one right here. This is row 2, column 1. That means there were 6 students in the humanities program that gave the humanities program a grade of 1. And so the table is populated. Next year, so once you get that, you're going to print it out as nicely as you can. And this is a suggestion, and it's a pretty good suggestion. Just I'd say stick with that. You know, use formatted, use printf, obviously. Next, you're going to tally the total number of responses for each program and store the results in a single-dimensional int array called total resp. So in other words, element 0. Oh, sorry. I already did the work here. So in this particular, for this particular set of data, curriculum 3, which is math science, should be the sum of this row, which would be 58. So total resp 3 is a single-dimensional array that would contain all of the elements, which is the sums of each one of these rows. Next, you're going to compute a GPA for each curriculum. Right? The GPA is going to be simply, and again, using math science as the example, it's going to be computed by this formula. You take the number of people that gave the curriculum a 0, multiply by 0. The number of people that gave it a 1, and multiply by 1. The number of people that gave it a 2, that should be a 13 right there. That should be the number 13, at least according to this right here. All right, so there's an error. That should be a 13. 18 times 3, 25 times 4. Divide by the total number in this right here, which is we've already computed, right? So divide by 58, and that would give us a 3.07. But in fact, I believe that number should be a little bit smaller because 13 times 2 would actually bring down the GPA a little bit. But you get the idea, so you should definitely check the math. And then once these computations are made, and we're going to store that again in a double array called GPA, where element 3 would contain the 3.07 or the correct calculation. Once these computations are made, present them in a nice fashion, maybe something like this. So totals in GPA, fine arts have 59 responses with a 2.18. Social sciences, 21 responses with the impossible GPA of 5.12. Obviously, that's not right. And so on down the line. Okay, and that's your project. Okay, so we're doing some work with multi-dimensional arrays. We're doing some work with single-dimensional arrays. We're doing some looped computations. There are some required methods, and then you can use what other methods you feel like defining. The important thing is don't perform redundant operations. Specifically, this number 58's already been calculated. Don't recalculate it. Reference it, okay, from where it's stored already. So I'm going to be looking for that. And other, obviously, make sure your program executes, has good design, good variable names, indented correctly, has a header, and print your name out before any other printouts are made. Okay, so I think that that's pretty sufficient explanation. If there are any questions, I'll be glad to go over it in subsequent lessons. So bring those to my attention. If that's all there is, I think we're good, and we'll see you next time. Bye-bye. Don't forget your homework.